Hello everyone. Today I am starting the second semester syllabus of JIS Group of the departments CSC, EC, IT, AIML, CST. Okay, so this course will be beneficial for all these departments. So before starting today's lecture, first of all, let's discuss the whole syllabus of your semester, second semester. Okay, so in your semester there are total 4 modules. First one, module 1, and module 1 is first order ordinary differential equation. Okay, module 2 is second order ordinary differential equation. Ordinary differential equation. Module 3, this is very important, that is Laplace transform. Laplace transform. And last module, module 4, this is numerical analysis or numerical method. Numerical methods. Clear? So for all these departments, CSC, EC, IT, AIML, CST. So for all these departments, the syllabus is module 1 first order differential equation, module 2 second order ordinary differential equation, module 3 Laplace transform and numerical methods. And this syllabus only for JIS Group. If you are from any other college, then you can search your topic in my playlist, and the name of the playlist is engineering mathematics. Okay, so let's start today's topic, that is module 1 first order ordinary differential equation. Module 1 first order ordinary differential equation. So before starting first order ordinary differential equation, let's discuss what are the contents in this first order ordinary differential equation. Actually, this first order ordinary differential equation, it has two parts. First one is first order and first degree. First order and first degree ordinary differential equation, ODE. ODE means ordinary differential equation. Okay, and the second one is first order and higher degree. Higher means more than one. Higher degree ordinary differential equation. Clear? So your syllabus first order ordinary differential equation is divided into two parts. First part is first order and first degree ordinary differential equation, and second part is first order and higher degree ordinary differential equation. You can see in your syllabus there are some unknown mathematical words. Which are the unknown mathematical words? First one, here you can see that one term is order. So you have to know what is the order of a differential equation. Second one is, here you can see differential equation. So what is differential equation? And differential equation is two types. First one is ordinary differential equation, and second one is partial differential equation, ODE and PDE. So you have to understand what is the difference between ordinary differential equation and partial differential equation. Okay, so we have to know what is the order of a differential equation, what is the degree of a differential equation, and what is the basic difference between ODE and PDE. Clear? This is our main topic in this video. This is lecture number 1. Clear? So let's start. First, we have to understand what is differential equation. Okay, what is differential equation? Let's discuss the definition of Ordinary differential equation or differential equation. Differential equation means an equation with some independent variable and some dependent variable and their derivatives. Okay, I am repeating. An equation with some independent variables, dependent variables and their derivatives. Okay, for example, let's write the definition. So any relation between an independent variable, dependent variable, okay, and one or more of the derivatives. Derivative, you can write derivative functions. Okay, is called ordinary differential equation. Suppose we can write the derivative in this form, dy dx. Yes or no? We can write the derivative in this form, dy dx. Now in this dy dx, which variable? Obviously here we have two variables, x and y. Yes or no? Now question is, which one is independent variable and which one is dependent variable? Can you tell me which one is independent variable and which one is dependent variable? When we are writing dy dx, that means this y is depending on x. So obviously y will be dependent variable. Yes or no? Y is dependent variable and this x, this is our independent variable. Okay, here it is given the definition as any relation between an independent variable, that means x, and dependent variable, that means y, and one or more derivative functions. Derivative function means maybe there will be dy dx, maybe d2y dx2, maybe d3y dx3, and so on. These are the derivative functions. Okay, and using this independent variable, dependent variable and these derivative functions, we can form an equation, and this equation is called ordinary differential equation. Now question is, why ordinary? Why it is called ordinary? Actually there are two types, ordinary and partial. So if any differential equation there is only one independent variable, only one independent variable, then the equation will be called ordinary differential equation. And if there is more than one independent variable, then the equation will be called partial differential equation. Independent variable means x, using which variable we are deriving the function. Okay, x is the independent variable. So if any equation there is only one independent variable, then the equation will be called ordinary differential equation. And if any equation there are more than one independent variable, then the equation will be called partial differential equation. For ordinary differential equation, we can use the symbol ddx, okay, when we are deriving any function. And for partial differential equation, we have to use the symbol del x. Okay, if the derivative is with respect to x, then we have to use del x. If the derivative is with respect to y, we have to write del y, and so on. Okay, this is the basic difference between ODE and PDE. ODE means there is only one independent variable, PDE means there are more than one independent variable. Clear? So what will be the example of ordinary differential equation? Suppose I am writing dy dx equals to let's say any constant k. Here the left hand side, this is the derivative of y with respect to x. Okay, here y is dependent variable and x is independent variable. So obviously we are getting a relation of dependent variable, independent variable and their derivative. And this dy dx, this is equals to k. So obviously we can say this is an ordinary differential equation. Okay, let's say suppose I am writing d3y dx3 plus 5 d2y dx2 plus 6 dy dx. This is equals to, let's say, 7x square plus 8x plus 9. Here in this equation here we have two variables, x and y. Okay, and obviously x is independent variable and y is dependent variable. Clear? And in this equation you are getting the relations between the derivatives. This is the d3y dx3, d2y dx2, dy dx, and the right hand side is a polynomial function of variable, independent variable. Okay, so obviously we can say this is ordinary differential equation. So this is very simple. You can identify any ordinary differential equation using this variables, independent variable, dependent variable, and their relations using derivative functions. Okay. Now, suppose I am writing del 2y del x2 plus del 2, let's say this is del 2z, del 2z del x2, del 2z del x del y plus del 2z del y2. This is equals to, let's say, 0. In this expression here you can see that the z is dependent variable. Okay, and here you have two independent variables. First one is x and second one is y. Okay, actually the variable which is in the denominator, this is your independent variable. Okay, in simple language or in simple concept, which variable is in the denominator, this is your independent variable. Okay, so obviously here we have two independent variables, x and y, and I have told you that if there is more than one independent variable, then the equation will be partial differential equation. Since it is partial differential equation, I have used the symbol del. This is the symbol of del. Clear? And if there is only one independent variable, then we have to use the symbol d. So I think it is very clear which is ordinary differential equation and which is partial differential equation, and what is the basic definition of ordinary differential equation. But remember, in your syllabus PDE is not included. Okay, in your syllabus PDE is not included, only ODE. Okay, so let's start the order and degree. This is our next part, that is order and degree of ordinary differential equation. Order and degree. Okay, so what is order? First of all, let me write the definition. The order of a differential equation is the order of highest ordered derivative. Okay, highest order derivative involved in the equation. Okay, suppose you are given an equation and you have to find out the order. So the definition is, first of all you have to find out the highest order term, highest order derivative. Okay, first of all you have to find out the highest ordered derivative. Okay, then the order of the highest order derivative. For example, suppose I am writing x dy dx whole square minus y dy dx, okay, plus c, this is equals to 0. Suppose this is the equation. Okay, now tell me what is the highest order derivative. Highest order derivative means how many times we are deriving the function. Here this is dy dx. Dy dx means one time derivative. Again this is dy dx. That means this is one time derivative. Now order means the order of the highest order derivative. That means how many times we are deriving the function. So obviously only one time. So here order will be order equals to 1. Clear? Here the order is 1. Now suppose I am changing the equation. Suppose this is x dy dx whole square minus y d2y dx2 plus c. Okay, I have changed the second term d2y dx2. Now tell me what is the highest ordered derivative? What is the highest order derivative? This is first order and this is second order, 2 times derivative. So obviously this is our highest order. And what is the order? Order is 2. 2 times derivative. So in this equation the order will be 2. Now suppose I am writing x d3y dx3 plus d4y dx4 whole to the power 5 minus y, this is equals to, let's say, any number x. Now tell me in this equation what is the order? What is order? First we have to find out the highest order derivative. Highest order derivative, this is third order, na? 3 times derivative, and this is fourth order, 4 time derivatives. So order will be 4. Okay, this is the concept of order. Now what is the degree? Degree means the power of the highest order derivative. Power of highest ordered derivative. Okay, this is the definition. Power of highest ordered derivative. Now tell me in this first equation what is the degree? In this first equation what is the degree? So first you have to find out the highest order. Which one is highest order? Obviously this one, d2y dx2, and definition is power of highest order derivative. And what is the power? Power of d2y dx2, there is no power, na? So degree will be 1. Clear? The d2y dx2 means this is, you can write this is whole to the power 1. So obviously degree is equals to 1. Now in this expression which one is highest order? Obviously order 4. And what is the power of order 4? 5. So the degree will be degree equals to 5. Clear? Let's write another equation. Suppose 1 plus d2y dx2 whole cube, this is equals to a square into d2y dx2 whole to the power 3. Now tell me what is the order and degree of this equation? What is order and degree? Order means highest order derivative. So obviously this is second order, and again this is second order. So order will be 2. And degree means power of the highest order derivative. In this case the power is 3, and in this case the power is again 3. So degree will be 3. Okay. Now very important. For every equation, actually every differential equation, for every differential equation order exists. Okay, for every differential equation order exists, but degree may not exist. Okay, for every differential equation order always exists, but degree may not. It is not necessary that degree always exists. Okay, why? There are some special type of equation. For example, that how you can identify that for a particular differential equation degree exists or not. Okay, so you have to understand some basic points. First of all, suppose you are given an ordinary differential equation. Okay, you are given an ordinary differential equation. First one is you have to find out which one is dependent variable. Which one is dependent variable? This is your first step. So first you are given an ordinary differential equation, and first of all you have to find out which one is dependent variable. Now in this dependent variable, if the dependent variable is in some index form, index form means let's say y is the dependent variable, so y to the power 3 by 2 or square root y or cube root of y, etc. Index form. Okay. Number 2, if there is any trigonometric function with dependent variable. Okay, or suppose logarithmic function, or suppose exponential function, okay, etc. So if in any differential equation with the dependent variable, if you can see this type of functions, then you can say that for that particular differential equation there is no degree. Clear? There is no degree. For example, suppose I am writing first example, suppose t into d2y dt2 plus t square dy dt minus cos of t into root over of y, this is equals to 2t square minus 3t plus 4. Okay, in this equation which one is dependent variable? Obviously y is dependent variable. And which one is independent variable? T. So y is dependent variable. Okay, so our first step is you have to find out the dependent variable. So this is our first step. So here y is our dependent variable. Now here you can see with the dependent variable y there is an index form, root over of y. Okay, so obviously in this equation what is the order? Highest order derivative, that means d2y d2, so order will be 2, but degree is no degree. Clear? Degree is no degree. Similarly, if I write, suppose I am writing the same equation, t d2y dt2 plus t square dy dt minus cos of t into y, this is equals to 2t square minus 3t plus 4. Now tell me what is the order and degree of this equation? Order is 2 because highest order is 2. And what is degree? Here I have written that if there is any trigonometric function, but trigonometric function with dependent variable, here we have cos t trigonometric function, but this is with independent variable, not dependent variable. That's why this will be not no degree. It has degree. And what is the degree? Power of highest order derivative. So degree will be 1. Clear? Okay, if you write degree, if you write no degree, just seeing that this is trigonometric function, so that will be wrong. Trigonometric function must be with dependent variable, then you can see that this is no degree. Okay, let's take another example. Suppose I am writing d2y dx2 plus x sin y, this is equals to cos x. Now tell me what is the degree and what is order? Order is highest order 2, and what is degree? Y is dependent variable, and here you are getting trigonometric function with dependent variable, so obviously no degree. Clear? Suppose next example, d3y dx3 plus square root of y, this is equals to 4. Now tell me which one is what is the degree and order? You will say that here y, this is your dependent variable, and there is index form, so obviously there will be no degree, but not, this is not correct. Actually this, you can write this equation in this form, that root y, this is equals to 4 minus d3y dx3, and squaring both sides you can write y is equals to 4 minus, actually if I simplify this, so this will be 16 minus 8 d3y dx3 plus d3y dx3 whole square. So if I simplify, so this will be d3y dx3 whole square minus 8 d3y dx3 minus y plus 16, this is equals to 0. Actually this is index form, but we can simplify this in a polynomial form. That's why this equation has degree. And what is the order? Order equals to 3. And what is the degree? Degree equals to 2. So here I have written a point that this is if there is any index form. So if there is any index form, that will be no degree only when we cannot write the equation in a polynomial. Okay, if we can write the equation in a polynomial form, then you can find out the degree. Okay, let's write another example. Suppose d2y dx2 plus d3y dx3 whole 3 plus log of y, this is equals to x e to the power y. Okay, or let's say this is equals to only y. This is the equation, d2y dx2 plus d3y dx3 whole cube plus y, this is equals to x e to the power y. So obviously in this equation, which one is dependent variable? Y. And here you can see this is e to the power y, na? Exponential, by according to the fourth condition, exponential. So obviously this equation will be no degree. Okay, and what is the order? Order is 3. Okay, I think order and degree, this concept is very clear. Now you have to practice all these questions. Okay, let me tell you, you can practice from the textbook Daspal. Okay, so before buying any textbook, obviously you have to check the index of the textbook. Okay, so that maybe Daspal volume 2, Daspal volume 2, you will get the 3 modules, module 1, module 2 and module 3, but the fourth module, that is numerical is not included in volume 2 Daspal. If you need any PDF of numerical, then you can message me on my WhatsApp number. Thank you so much.